This video, we're going to go over number 1 from the chapter 15 homework. So we're given a, looks like 3 different probabilities. So let's write those down. We have biology majors at a university requires them to take a course called bioresearch. That sounds intense. The prereq for this course is a stats course, which hopefully everyone's taking that, or a computer course. By the time they're juniors, 52%, so this is stats, 52% have taken stats. Okay, and how many for computer? 0.23. And how many for stats and computer? And if you want to put both, you can put both. 0.07? I didn't want to put both. Personally, if I'm doing this problem, I'm putting both. But I wanted to show you that is. When it says both, that's and, right? Stats and computer. Did they need to take both? No. Just needed one or the other. Okay, so first question. What percent of the junior biology majors are ineligible for bioresearch? Ineligible for bioresearch. Okay, so actually the way that I'm going to answer this question is first find out how many, or I should say what probability, are eligible. Because if I find the probability that are eligible, then I can always subtract this from 1. Do you remember what that word is called when you take it away from 1? What was it? No, I mean that is subtraction, difference. That was Thomas. Complement is correct. That was Jonathan. Complements. All right, the complements. All right, so let's find eligible. So if they were eligible, that's stats or computer. Yes? Stats or computer. All right, we just talked about this formula. We're going to add stats plus computer, and then take away the ones that are both, that have taken both. So I don't want to double count, because I know it's weird to say this, but the students that have taken both are being counted in these other ones. So we don't want to double count. That's why we take away the both. All right, because you'll see in a moment when we answer question C, they're not disjoint. Okay. All right, so probability of stats plus probability of computer, and then for space sake, I'm going to just put subtract both. All right, and we know all this stuff. Stats is 0.52 plus computers 0.23 minus 0.07. And I apologize. You can stay there, just grab it. Oh. Yeah, you should be able to do this one. We're going to get this multiplication division. That's a little tougher. No worries. Yes, question? Thank you. No, all right. Good. All right. So let's go ahead and do it real quick. I hope you know this is not the answer, right? This is not the answer. This is just the probability of the juniors that are eligible to take this bioresearch course. What is the probability that they are eligible? Was it 6.8? Yes? All right. So this is eligible. Okay, but again, we don't want eligible. We want ineligible. So let's go ahead and do 1 minus 0.68, which is going to give us 0.32. All right. So what percent of the juniors, I should say junior biology majors, are ineligible for bioresearch? 32%. That seems high, right? Not a great job by this college and their advisors. You hearing that? Yeah. Okay. Ready for B? Did you harmonize with it, Maria? Yeah, you did. All right, let's do B. Let me pause. Everybody okay with A? I know we've never used that formula before, but it's very similar to last week, but we're throwing this both because we don't want to double count. All right, they are not disjoint events. We'll prove that in a moment. All right, B. What's the probability that a junior bio major who has taken statistics? So when I read this, I try to make it clear, right? They're telling me what right now? This student, or these students, have taken statistics. When you read something like this is shouting at you, and maybe not yet, right? Maybe it's whispering right now. In a few weeks, hopefully it's shouting. This is a conditional probability.
So this is one where it's like A and then B happens.
It's the given, yeah. So conditional.
The given is the statistic.
Exactly. So I'm going to find the probability that they're going to take a computer course given, right? Given they've already taken stats. All right, so I'll write the formula down. And again, you will have the formula sheet on Wednesday. All right, I probably won't give you the sheet. I'm just going to write on the board or post on the screen. But you will have these formulas in front of you. Okay? So the way I memorize it is what has happened. What do you know has happened about these students? They took stats. So I put in the bottom, I put what's happened. They've taken stats, right? And then in the top, right, if you know they've already taken stats and we want to know the likelihood that they've also taken computer, then on the top is always going to be both, right? And you can write stats and computer, or you could write computer and stats. It doesn't matter, right? Because that's going to be the same. So on the top is both. Do we have these probabilities? Do we have both? The probability that the students have taken both? Yes, we have that one. Do we have the probability of stats? We do. So it's going to be 0.07 is both. And I believe stats was 0.52. Very good. So take a moment in your calculator to find this answer. Usually that one. Is it batteries?
No, it keeps turning on. Maybe it is.
You could just
Oh,
toss.
now it went away.
Okay, well, if it still is not working, you just put it in front. Anybody have an answer? 0.13? Does that make sense? Because in that division. All right.
One of the probabilities would be manipulating the equation.
Good question. If you're missing, like if they have a problem like this and they're missing, if you're missing one, hopefully you have enough information to use the other formula to find the missing one. There's no way, and we'll see when we do the review after Thanksgiving, there's no way that that you can't find it. It might be more challenging because you got more steps, but you should be able to. Everybody good on B, the conditional? And if you're not seeing it yet, don't worry. We'll keep practicing until you see the given. Okay. Are they disjoint? I think this one's pretty simple. If you're seeing it, if you're not seeing it, maybe not simple, right? If they're disjoint, as Jonathan told us, right? If one happens, the other can't. So if somebody takes stats, they can't take the computer course. If somebody's taking the computer course, they can't take stats. We know that's not true because what percentage have taken both? 7%. So no, because exactly. I'm actually going to put 7% of the juniors or junior biology majors have taken both. But if you want to write there are students that are taking both, that's also correct. All right, so I think this one you're going to see is going to be a little simpler than trying to figure out if they're independent or not. All right, so let's talk about independence. Think back to last week. What did we say about independent events that you wrote on your quiz last Thursday?
When one occurs, it doesn't affect the probability of the other.
Exactly. So if this event occurs, the event over there, whether it's happening or not, I don't know, but the likelihood that it's going to happen is unaffected. Okay, so here's how you do it, all right? There's two ways you can do it. You can do the probability of A equals the probability of A given B has happened. If that's a true statement, then these are independent events. Or you could do the probability of B is equal to the probability of B given A. And this is not a formula they're going to give you. So they ask you to prove mathematically whether two events are independent or not. You do need to do this. I'm hoping we can handle this, right? So here's the probability of that one happening, all right? I tell you this one happens, right? That's the given. I tell you this one happens. If that's the same as this, then they're independent, okay? So you just need to pick one. Do you want to pick stats or do you want to pick computer course? Stats course or computer course? Doesn't matter. Stats? Yeah, always choose stats. Come on, guys. You're in stats class. Okay, so the probability of stats. All right? And we know this, right? We know the probability of stats. What was that from the very beginning? Wasn't it 5-2?
Yeah.
Yes. Okay, but now I need to see if it's independent by doing the probability of stats. But now what am I telling you has happened about this student? They've taken the computer course. All right, so this is a conditional probability. All right, so we have, I'll do the math there. So that's going to be equal to, and the bottom is computer, and in the top is going to be both. All right, both was 0.07, correct? And computer was, I already forgot, 2.3? Yeah, 0.23. All right, so take a moment. Is 0.07 divided by 0.23 the same as 0.52? What is 0.07 divided by 0.23? 0.3? So they are not equal. So if they're not equal, and I get this question every year, how equal is equal? It's up to you, right? Because I'll get students that have like 0.3 and 0.29, and they'll say, yeah, they're independent. All right? Here's what I'll say, because this is going back to September, right? We did actually do this informally in September with Chapter 3, all right? What I say for students is if the AP exam is giving you probabilities, right? In this problem, you've got probabilities. It's not like a table. Then I'm looking for exactly the same. Okay? If it's not exact, I'm not saying they're independent. So in this case, they are not independent. Do you want to see the work if we had chosen computer? Yes? Shall we show the work if we'd done the other one? Again, does it matter? Do you have to do both? No, don't do both. Just choose one. Just choose one. Just choose one. So this would be probably of computer. Yeah, well, we already did this one earlier. It was 0.23, right? So now it's going to be computer. So the likelihood that it took computer, given that they've taken stats. And we actually found this one. Wasn't this part B?
Yeah.
What do we say? Part B was 0.13. Are those the same? They are not. So these are not independent.
You said do that. You can do that with only one. You can do that with
Yeah, don't like because this one I already did this work, and these are not the same. You told me this was like 0.3 approximately, right? So in this case, they're not the same. So don't do both. I'm showing you can do either one. Just choose one.
Even if it's the same, just do one.
Oh yeah, if you do one and you get that they're the same, and so you know that they're independent, just stop. You know they're independent. You don't need to do both to confirm.